Deep inside a data center, there is a piece of silicon that costs as much as a luxury car. The H100, a beast capable of 1,000 teraflops of mathematical violence. But when you type a prompt into ChatGPT, this $30,000 beast isn't roaring, it is waiting. It is arguably the most powerful calculator humanity has ever built, and it spends most of its life doing absolutely nothing. Why? Because of a fatal flaw in modern computing architecture. A flaw known as the memory wall. The chip is a Ferrari engine, but we are feeding it fuel through a coffee stirrer. The math is instantaneous, but moving the data, the fuel, from the memory to the core takes an eternity in computer time. When OpenAI launched, they faced a terrifying math problem. To serve 100 million users with a 170 billion parameter model, the memory wall shouldn't just make ChatGPT slow. It should make it financially impossible. They needed a way to cheat the physics of hardware. Here is how they did it. The first problem was a tragedy of inefficiency. Imagine reading a book, but for every new word you read, you are forced to reread the entire book from the very first page up to your current point. That is how a naive transformer model works. It is autoregressive. To predict word 10, it processes words 1 through 9. To predict word 11, it processes 1 through 10 again. It is the most redundant calculation in the history of computer science. As the conversation grows, the math creates an exponential explosion of wasted work. The engineers looked at this and realized, we are calculating the same numbers over and over again. The solution was KV caching. Instead of throwing away the calculations for the past words, the keys and values, we freeze them. We lock them in memory. Now, when the model predicts the next word, it doesn't reread the book. It just glances at its notes. We turned a quadratic disaster into a linear breeze. But this created a new problem. We solved the compute bottleneck, but we filled the memory with cache. So the chip is faster, but now we have a traffic jam. A server handles thousands of people at once. The old way to handle this was static batching. You group 4 people together, put them on a bus, and the bus doesn't move until everyone is done. But imagine user A asks, what is 2 plus 2? And user B asks for a PhD thesis on quantum physics. User A finishes in 10 milliseconds. User B takes 30 seconds. For 29.9 seconds, user A's seat on the bus, that distinct lane on the GPU, sits empty. The beast is starving again. Wasted cycles, wasted money. The fix came from a system called Orca. They stopped thinking about requests as buses and started thinking about them as Tetris. This is continuous batching. The moment user A finishes their tiny question, the system instantly ejects them and slots in a new user into that empty space. No waiting, no polite queuing. Suddenly, the GPU goes from 30% utilization to 95%. Throughput triples. Same hardware, 3 times the users. But there was one final trick left, the most dangerous one. We optimized the memory. We optimized the scheduling, but we were still limited by the speed of the model itself. GPT-4 is a genius, but it is heavy, it is slow. The engineers noticed something counterintuitive. It takes GPT-4 roughly the same amount of time to write 1 word as it does to proofread 5 words. Why? Because writing is sequential, but proofreading can happen in parallel. So they decided to gamble. This is speculative decoding. They employ a second model, a tiny, fast, dumb model. Let's call him the intern. When you ask a question, the intern sprints ahead, wildly guessing the next 5 words. He's often right, but sometimes wrong. It doesn't matter, he's fast. He hands his messy draft to GPT-4. GPT-4 looks at the 5 words all at once in a single glance. If the intern was right, GPT-4 stamps them approved. We just got 5 tokens for the price of 1. If the intern was wrong, GPT-4 discards them and takes over. It's like having a ghostwriter draft your emails and you just hit send. This trick alone doubled the speed of ChatGPT overnight. KV caching, continuous batching, speculative decoding. These aren't just software updates. They are the intricate, invisible architecture that keeps the beast fed. Without these 3 innovations, the AI revolution would have died in a server room, crushed by the weight of its own memory. System design isn't just about making things work. It's about finding the bottleneck and shattering it.